Alrighty, we are starting our last chapter of geometry. Chapter 12 is all on three-dimensional figures. Our first section, 12.1, explore solids. So we're going to identify different solids. So we're going to start with identifying what is a polyhedron. A polyhedron is a solid with all polygon faces. So when we look here, there's a line. These are not polygons, they're not polyhedron because these have circle bases. Over here, these are polyhedra. Polyhedra is the plural form of polyhedron. I do not know why it's not polyhedrons, but the plural term is polyhedra. Alright, there's a couple things we need to talk about with polyhedra. First, base. A base is any non-rectangular or shaded. Alright, remember the base will usually be shaded. Otherwise, if it's non-rectangular, like a pentagon, for example, as we see here, that will be your base. When naming them, there are two types of polyhedras. We're going to have pyramids and prisms. A prism is one that the bases, you have a base on both ends, and it's named by the shape. In this case, the base is a rectangle, so it's a rectangular prism. Down here, this prism has a pentagon for a base, so this is a pentagonal prism. And over here, we have a pentagon base, and all the sides come to one point. That is called a pentagonal pyramid. Over here, the things that weren't, we have a cone and a cylinder. Another one you'll see would be the sphere. Alright, edge. Any of these faces, they're also called a face, is a side. An edge is this line right there. That would be an edge. Where two edges meet, that point is called a vertex. Euler's theorem talks about the relationship between the faces, vertices, edges of a polyhedron. So, very important. The number of faces plus the number of vertices is equal to the number of edges plus 2. And we'll go through an example right here. So, list the number of faces, vertices, and edges on the piece of cheese. Alright, so faces, vertices, and edges. First of all, what is this shape? It is a rectangular prism. How many faces are on it? Well, there's this side and the back. So that's 2. The front face you see here and the one behind it, as well as the bottom and top, for a total of 6 faces. How many vertices are there? The vertices would be 1, 2, 3, 4, and on the back side 5, 6, 7, 8. So we have 8 vertices. Number of edges: 1, 2, 3, 4. In the back, 5, 6, 7, 8. And along the sides, 9, 10, 11, and behind there would be 12. To check with Euler's, faces plus vertices equals edges plus 2. And in fact, we get 14 equals 14. So that is one way we can know that we are correct. So is the object at right a polyhedra? Well, it has a square base, triangle faces, also called sides. So it is a square pyramid. And a square pyramid is in fact polyhedron. All right, concave versus convex. We've seen concave and convex before when talking about a two-dimensional figure in a plane, when talking about sides. What we say is the line between two vertices is inside the solid. So I can pick any two vertices on the solid and draw a line between them, and it's going to be completely within the solid. Here, the line between two vertices may go outside the solid. So for example, if I pick these two vertices right there, I draw the line between them, that line is completely outside. That makes it concave. Regular polyhedra, all faces are congruent, regular polygons. And there are 5 of them, and they are called the Platonic solids. You should also know they are named after Greek philosopher Plato. And there are 5 of them. You've seen some of these before. The tetrahedron, it has 4 triangular sides. The most common, right here, the cube is actually a hexahedron. Octahedron, 4 on top, 4 on bottom, 8 sides. Icosahedron, again, all triangles on that one. And then the dodecahedron is 12 pentagons. The last thing in this section is we're going to talk about cross sections. And a cross section is the result of a plane intersecting a solid. So as you can see here, in the pinkish color, a plane is drawn such that it goes through. This could kind of be like if you were cutting something with a knife. The knife would be like a plane, and whatever you're cutting would be the solid. And so our cross section would be, what do you see after the cut? So like if you're cutting cheese, what is the shape of the cheese after you cut it, that piece that results? So describe the shape of the cross section of each solid below. And as you can see, this is a triangle. With this one, if the cross section is parallel to the base, the circle. If it's drawn that the cross section is clearly not, you're going to get an oval, or we call it an ellipse. So it will be clear when it is not parallel. And lastly, 6 sides make a hexagon.